Hello everyone, welcome to Primus Learning. It's Aziz here today, and we're going to be looking at how to set up a Kubernetes cluster using Kubeadm. And we are going to be doing that by using two EC2 instances, which we are going to launch later. We are going to call one our Kubernetes control plane, and then we are going to create another EC2 instance for our worker node. So that's basically what we are going to be doing for today, and we are also going to be installing all control plane components, and also we are going to be using WeaveNet as our network plugin. So we are going to create one EC2 instance for the control plane using Ubuntu 20.04 LTS, and we are going to use a T2 medium, so as to ensure that all the components are up and running and everything is working very well. And then we are also going to create two security groups, one for the control plane and one for the worker nodes. And in our security group for the control plane, we are going to be opening all these ports. We are going to be opening 6443 TCP for our Kubernetes API server. We are going to be opening 2379 2380 for our etcd server, and all the other ports that we are going to need for all our networking components and our Kubernetes node ports. We are also going to open this set of security groups for the worker nodes. We are going to open the 30,000 to 32,767 for our node port services. And then we are going to go ahead and install all the necessary components in our Kubernetes control plane and our worker node. So let's go to AWS. I'm going to my AWS account. I'll go to EC2. First, I'm going to create the security groups because I prefer the interface when you're creating the security group from here instead of when you're creating it while launching the instance at the same time. So I'm going to create two security groups. Let's call this one the cluster security group, or let's call it the control plane security group. Control plane security group, and we are going to be using the default VPC. Let's use the default VPC. I'm going to open inbound role. Let's open SSH, since we are going to need SSH to be able to SSH into our control plane and install all the necessary components. And after that, let's open some generic ports like HTTP. Let's open some generic ports like HTTP and HTTPS. HTTPS. Okay, let's come back here. Now let's open 6443 TCP for our Kube API server, custom TCP 6443, and we are going to do that from the internet. And let's open these ranges. I'll just copy this for our etcd server. Paste this from the internet. Let's open 6783 TCP for our WeaveNet CNI. 6783 custom TCP tag, and then we're going to create custom UDP 6784, I believe 6784. We come back 6784 from the internet, and next we are going to create 1024.8 and the 10.260 for our kubelet API, our kube scheduler, and all the other control plane components. So I'm going to open this range too. Sorry for the background noise. And then we are going to open our node ports. very important for our node port services. Voila, I think that should be good. Let's go ahead and create this security group. What did we call it again? Control plane security group. And for outbound, we can I'll just allow all traffic, and create. Okay, so let's remove this. It says the security group all for outbound already exists. Role with source. Oh, okay, security group name already exists. Let's call it control plane. Control plane. And create security group. Let's verify to make sure that our outbound security group, so the outbound role was not actually created. So let's go ahead and create it to all traffic from the internet. Okay, very good. Back to security group. Go again to create security group. Let's create the worker nodes security group. I'll just call it workers minus sg. Workers minus sg. Copy the same thing for description, and we're going to be creating it in the default VPC. Let's open some generic ports. First, I'll open SSH because we need SSH access to be able to configure the server. And then I'm going to open some generic ports like HTTP and HTTPS. Why not? HTTPS. And now let's go ahead and open our node ports services. Tag. Add row. After that, let's go ahead and open up the 10.20.48 for our Kubelet API. And then we can open the 2783 TCP, 2783 from the internet, and then let's open the UDP 2784 from the internet. And what else? I think that is it. Yes, and we're good. Let's add an outbound role for all traffic from the internet and create security group. Okay, back, it keeps on saying Pierre, this already exists. I'll remove it and we can create it after. Worker security group. It keeps on doing this funny stuff. Okay, no outbound row, edit. Let's open up all traffic from the internet and we can save. Okay, we have our two security groups, control plane security group, and we have the worker nodes security group. take, let's say this one has inbound, okay, outbound, all traffic, it's good. So let's go ahead and spin up our instances. Open this in a new tab, go to launch instances. Let's call this the control plane. Let's call this the control plane. I'm going to select Ubuntu, and we are going to be using Ubuntu 20.04 LTS SSD volume type. Yes, I'm going to scroll down and let's go ahead and select T2 medium. And for the key pair, I'll just choose an existing key pair. You can go ahead and create one if you don't have one. I'll just select an existing key pair that I've already uploaded to my SSH connection application. So I'm just going to select that. And then under security group, I'll just click on select existing security group. And then I'll select control plane security group. And after that, that should be all. And then we can go ahead and launch our instance. Okay, we are done for the control plane. Let's launch another one for the worker node. Back to launch instances. I'll call this one the node. We're using Ubuntu AMI, and we are going for the 20.04 LTS SSD volume type. Great. And then we want to go for the T2 medium, 2 vCPUs with 4 GB of memory. And then for the networking part, I'll just do select an existing security group, and then I'll select our workers security group that we created. I think this one is the one that was okay. Use this one, and I think that should be it. Okay, key pair, sorry, Kubernetes key pair, and launch instance. Okay, and go back to instances, and let's wait for our instances to be up and running. I'll just see state instance state is equal to, and then I'll say run. Great. So let's wait for our worker node to be up. While the worker node is coming up, I'm going to go to my SSH client. I'm going to go to my SSH client, and I'm using Terminus for Mac. So you can use any SSH client that you want if you have Git Bash or you want to use your command prompt or anything. But I'm going to be using Terminus for Mac because it's already integrated with my AWS environment. So let's check if our worker node is up and running. Okay, our worker node is up and running. I'm just going to restart Terminus. Let me restart the SSH terminal. Oh. Okay, I'm going back to host. Oh. Why is it not able to automatically discover my AWS hosts today? I'm just going to add the host address. I'm going to copy the public IP. Add public IP. SSH that username is equal to Ubuntu. and then I'll set a key, and I'll use Kubernetes key. I think that should be all. Okay, all changes have been saved. Let's try to see if we can be able to have access to the host. Add and continue. Okay, looks good. Let's see if we can rename this to our control plane. Okay, control plane. Now let's add another host. Let's add another host, new host. Let's go, I'll select the node, public IP. I'll put in my public IP. The username is equal to Ubuntu. Great, and then I'll set a key, and then I'll just select the key that I already have existing, and that should be it. I'll try to connect, add and continue, and then I'll just rename this to node. Okay, great. Now we are good to go. Let's go back. So the next steps, first let's disable swap off so that our Kubernetes can be able to schedule our ports very well. For that we need to disable swap, because at the moment Kubernetes is not managing swap memory very well, so we need to disable the swap for Kubernetes to be able to manage our our memory requests and our memory requests and limits very well. We need to disable swap. So I'll be running these commands on both the first I'm going to switch to root. Okay, swap off, come down to the node, sudo switch user root, clear my screen a bit, and then swap off. Okay, now we need to install containerd. Because we need a container runtime environment for Kubernetes to be able to pull our images. So we are going to be using containerd, because Kubernetes no longer supports Docker Engine as the base container architecture. So we need to use containerd. Okay, so we need to install runc. I'll go to the node and I'll install runc. Now we need to install our CNI. Okay, in the control plane we need to do same. And we also need circtl, installing circtl, back on the node, installing circtl. After that, let's complete the installation. Clear it up a bit. Okay, back to the control plane, I'll do the same. And then to be able to let our IPv4 to discover breached network or breached traffic, we need to run this. Just run this at same time. And also same thing on the control plane. Come down. Okay. Now let's go ahead and begin the installation for the kubectl, kubelet, and the Kubeadm. Let's start installing the major control plane components, or the major components for our Kubernetes cluster. Let's hold on for the installation to be complete, and after the installation is done, then we can go ahead and run this on our Kubernetes control plane for Kubeadm to pull all the necessary images. Okay, everything looks good. Cancel, clear, and then Kubeadm not found. I need to run this again. First, let me run this independently. Okay, run again here, and let's run this to install. Okay, and stay in the control plane. Let's wait for the components to get installed, and then we can on Kubeadm config pull images. Okay, Kubeadm config images pull. So Kubeadm is now pulling all the necessary images to run them in our Kubernetes control plane. It's running the kube API server, the kube controller manager, the kube scheduler, the kube proxy, and all the necessary ports that we need for our Kubernetes cluster. And that is it. After that, we can now run Kubeadm init with the public IP address of our worker node of our control plane. Sorry. So I'll go back to the control plane, and we get the public IP address and tag. That is it, and enter. Waiting for the kubelet to boot up. The control plane as static ports from directory. Now after that is done, let's go ahead and have our worker node join the cluster by running this command on our worker node. Okay, we are good. And now the next thing you want to do is you want to export this. To start using your cluster, you need to run the following as a regular user. So, but before we do that, anyways, let's switch to a regular user. The next thing we want to do is we want to install our CNI. Before we want to install our pod networking, you can see you should now deploy a pod network. We need a pod network for our cluster to be able to discover all the nodes and all networking, because that is what is in charge of managing the networking in our Kubernetes cluster. So we need to install, and for that we are going to be using our WebNet. So let's go ahead and run this. I'm going to exit from root, and then I'm going to execute this as Ubuntu user. Okay, now if you do kubectl get nodes, kubectl, okay, let me clear that up. Kubectl get nodes, you see the nodes are not ready. So for this we need to go ahead and install our CNI. kubectl apply -f, everything is created. Now let's check if our nodes are up. Not yet ready. Voila, everything is up and running. And that is it. Now we have our Kubernetes cluster running on AWS. If you want to be able to connect to your Kubernetes cluster from local, you just need to do the same thing. I can open up a local terminal. All you need to do is open up a local terminal, and I can do cd into .kube because I'm already in my home directory. I can do cd into .kube. See if I can make this a little bit bigger for you guys. Yes. Now inside here, I'm just going to replace this config file. So I'm going to do a vi into config. I'm going to do colon and %d, delete all, and then I'm going to replace it with the kube config from here. So I'm going to do a cat on .kube /config. Yes, and then we simply grab our kube config, copy, and then we are going to paste it over here, and then escape colon wq, and then kubectl get nodes. And now we are connected to our control plane from local, and you can be able to run all your necessary Kubernetes commands. kubectl get namespaces, and everything is good. So that is it. Now you have your Kubernetes cluster running on AWS, and everything in this tutorial is going to be inside the description. So inside the description, you're going to find a link to our GitHub repo where you can be able to get this PDF to be able to run your Kubernetes cluster on AWS. Thank you very much. Don't forget to subscribe. Peace. Bye bye.